Next formula is L of sin h at is equal to a by s squared minus a squared. Let me prove this now. We'll apply the formula sin h at is equal to integration of 0 to infinity e power minus sg sin h at dt. So this, you don't have the combination of the exponential and sin h. What we are going to do is we are going to write sin h in terms of exponential. So this will become integral 0 to infinity e power minus st. So what is sin h at? E power at minus e power minus at by 2 into dt. So now this will become, I can take this 1 by 2 outside. So integration of 0 to infinity e power minus s minus a. Let me separate this. So this, let me split the integration. This is one term, the other term will be minus integration of 0 to infinity e power minus of s plus a into t dt. Let us integrate this. This is equal to 1 by 2 into e power minus s minus a into t by s minus a. So you are having a negative sign. This is from 0 to infinity minus e power minus s plus a by s plus a, and you do have a negative sign for the integration. This is into t. So this is from 0 to infinity. So looking into the upper limit, if you substitute the upper limit, this will become e power minus infinity. It is obviously 0. So the lower limit is 0, so you will be getting 1. So this term will become s1 by s minus a, and this term will be getting 1 by s plus a. Let me write this properly. That is half you have in common into 1 by s minus a minus of 1 by s plus a. And if you take LCM over here, you will be getting s plus a minus s plus a by, this will become a squared minus b squared. So s squared minus a squared. So my s will get cancelled, and I'm having 2a by 2 into s squared minus a squared. 2 will get cancelled. This will become a by s squared minus a squared. So hence the proof. Next, let us prove L of cos h at is equal to s by s squared minus a squared. So again, the same as sin h, we are going to convert sin h into exponential and we are going to proceed. So L of cos h at is equal to, we'll apply the formula, integration of 0 to infinity e power minus st cos h at dt. This can be written as integral 0 to infinity e power minus st e power at plus e power minus at by 2. So this is what cos h is into dt. This is equal to 1 by 2. Let us split the integration here. So 1 by 2 into integral 0 to infinity e power minus s. We will take the negative sign outside. S minus a into t dt plus integral 0 to infinity e power minus s plus a into t dt. So let us integrate this. 1 by 2 into e power minus s minus a into t by s minus a. You have a negative sign, so I am putting minus, plus this is from 0 to infinity plus e power minus s plus a into t by s plus a. Again you have a negative sign, so this is from 0 to infinity. So when you look into the upper limit, so it is infinity, e power minus infinity will become 0. So the upper limits is not, you don't have to consider, it is 0. Look into the lower limit, it is 0. When you apply 0 here, it will become e power 0, that is 1. So you will be getting 1 by s minus a over here, and you will be getting 1 by s plus a for the second term. Let us write this properly. This is equal to, we have 1/2 outside, so 1 by 2 into 1 by s minus a plus 1 by s plus a. Let me take LCM for this. S plus a plus s minus a by, this is a squared minus b squared formula, so a squared minus a squared. Our a terms will get cancelled, so this will become 2s by 2 into s squared minus a squared. 2 will get cancelled, this will become s by s squared minus a squared. Hence the proof. So now we have a set of formulas. So in particular, if you see, we have a set of formulas and we are going to use those formulas in our problems. That is, our formula number 1 is L of 1 is equal to 1 by s, and L of t to the power n is equal to n factorial by s to the power n plus 1, and your n is equal to 0, 1, 2, etc. And our third formula is L of e power at is equal to 1 by s minus a, and our fourth formula is L of sine at is equal to a by s squared plus a squared, and L of cos at is equal to s by s squared plus a squared. And our sixth formula is L of sin h at is equal to a by s squared minus a squared, and L of cos h at is equal to s by s squared minus a squared. So we are going to use all these formulas. We are having around 7 formulas we are going to use. Just keep it in mind, we are going to use it in the problems. Next, let us see first shifting theorem. This theorem states that if L of f of t is equal to f bar of s, then L of e to the power at f of t is equal to f bar of s minus a. So we have to prove this. By definition, we know that L of e power at into f of t can be written as integral 0 to infinity e power minus st, and instead of f of t we have e power at into f of t, so we have to write that e power at into f of t dt. So this can be written as e power minus s minus a into t f of t dt. Now this is of the form e power minus, and instead of s we have s minus a e power minus st f of t dt. So instead of s we have s minus a, so we can write this as f of s minus a. This is called the first shifting theorem. We are going to use this shifting theorem to get the other set of formulas. That is, we all know that L of 1 is equal to 1 by s, and if we use the shifting theorem, that is, if we use the exponential term, this will become, we are going to shift s as s minus a. So this will be the new formula. So let me write this properly. L of e power at is equal to 1 by, instead of s I am going to shift this as s minus a. So the second formula, we all know L of t power n. So L of e power at into t power n will be, what is L of t power n? Is equal to n factorial by s to the power n plus 1. So here what we are going to do is, we are going to shift s as s minus a. So we will do that. This can be written as n factorial. We are going to shift s alone. So instead of s I can write it as s minus a the whole power n plus 1. So this will be the formula. Similarly, L of e power at into sin bt. So what is L of sin at? It is a by s squared plus a squared. So here we have sin bt and we have the exponential term. So this can be written as, instead of a we have b here. So b by, instead of s I am going to shift it, s minus a the whole square plus b square. So similarly we can write the cos. So L of cos at is s by s squared plus a squared. So here we have b instead of a, so I am going to write it as, so yes I have to shift, so it is s minus a by again s squared, so s minus a the whole squared plus b squared. My next formula will be L of e power at sin h bt. So we all know the formula again. So for sin h at it is a by s squared minus a squared. So instead of a we have b here. So it is b by, I have to shift this s as we have exponential term. So it is s minus a the whole square minus b squared. Next is e power at cos h. Again cos h we can write this as, it is s by s squared minus a squared for cos h. So we have exponential term, so I am going to shift it. Instead of s I am going to write s minus a by s minus a the whole square minus b squared. Keep this as a formula, or you can simply use the previous formulas and you can shift for e to the power at. Next we will move on to some problems. Find the Laplace transforms of 7 e power 2t plus 9 e power minus 2t plus 5 cos t plus 7 t cube plus 5 sin 3t plus 2. Let me solve this. Now let us apply the formula. L of 7 e power 2t plus 9 e power minus 2t plus 5 cos t plus 7 t cube plus 5 sin 3t plus 2 is equal to, we have to separate the terms right now and we will take out the constant. 7 is a constant for the first term. So 7 into L of e power 2t plus 9 into L of e power minus 2t plus 5 into L of cos t plus 7 into L of t cube plus 5 into L of sin 3t plus 2 into L of 1. So if it is a constant you have to write it like this, 2 into L of 1. Now let us apply the formula one by one. 7 into, so what is e power at formula? It is 1 by s minus a. So instead of a you have 2 here. So this is 7 into 1 by s minus 2 plus 9 into, so here you have minus 2. So it is 1 by s plus 2 plus 5 into, so what is cos formula? It is s by s squared plus a squared. So instead of a you have 1 here. So it is s by s squared plus 1 squared. Next is 7 into t to the power 3. So t to the power n formula, that is n factorial by s to the power n plus 1. Here n is 3. So 3 factorial by s to the power 3 plus 1 plus 5 into sine. What is sine? Sine 80. So a by s squared plus a squared. So a, instead of a you have 3. So it is 3 by s squared plus 3 squared plus 2 into, what is L of 1? It is 1 by s. So this is equal to, what about the first term? It is 7 by s minus 2, that is 7 by s minus 2. The second term, 9 by s plus 2. So it is 9 by s plus 2. Plus the third term is 5s by s squared plus 1. 5s by s squared plus 1. So what about the next term? It is 3 factorial into 7. So 3 2s are 6. 6 into 7, it is 42. So 42 by s to the power 4. So 42 by s to the power 4 plus next term is 5 3 is 15. So 15 by s squared plus 3 3s are 9. So s squared plus 9. So 15 by s squared plus 9. The next term is 2 by s. So plus 2 by s. So this will be the answer. Before moving to the next set of problems, just have these formulas in handy. That is sine into cos, cos into sine, sine x, cos y. So these trigonometric formulas will be very helpful for solving the next set of problems. So sine x cos y is equal to, we all know this, but anyway I'll write this once. It is 1 by 2 into sine of x plus y plus sine of x minus y. Likewise, cos x sine y is equal to 1 by 2 into sine of x plus y minus sine of x minus y. And we'll write the other combinations also. It is sine x sine y. So this is equal to half cos of x minus y minus cos of x plus y. Next is cos x cos y. Cos x cos y will be equal to 1 by 2 into cos of x plus y plus cos of x minus y. Next we will see cos squared and sine squared. So cos squared, we all know cos squared theta is equal to 1 plus cos 2 theta by 2, and sine squared theta is equal to 1 minus cos 2 theta by 2. So the second set of problems, find the Laplace transforms of first one, sine 2t sine 3t. So we don't have the formula for L of sine into sine. So of course we are going to use the trigonometry formula for sine into sine. So what is the formula? Sine x sine y. So sine x sine y is equal to half into cos of x minus y minus cos of x plus y. So we are going to use this. Let me apply the formula. L of sine 2t sine 3t is equal to, so first we are going to use the formula. So it is half into, let me apply the Laplace transform also. It is cos of x minus y or y minus x, anything you can take. So let me take it as 3 minus 2 into t minus cos of 3 plus 2 into t. So this is equal to half into L of cos t minus L of cos 5t. Now we can apply the formula. So what is L of cos? S by s squared plus a squared. So instead of a you have 1 here. So let me write it as s by s squared plus 1 squared minus, instead of a you have 5 here. So this will become s by s squared plus 5 squared. So this is equal to 1 by 2 s by s squared plus 1 minus s by s squared plus 25. So this will be the answer. Second problem in this will be L of cos squared 2t. So again, we don't have any formula for L of cos squared, so we are going to apply cos squared theta formula. So it is 1 plus cos 2 theta by 2. So let me take this 1 by 2 outside. So I am going to write this as 1 plus cos 2 theta. So theta here is 2t. So 2 into 2t. So it is cos 4t. So we have two terms here. One is L of 1 and the other one is L of cos 4t. So what is L of 1? It is 1 by s. So what is cos formula? It is s by s squared plus a squared. So I can write this as s by s squared. Instead of a squared you have 4. So it is 4 squared. So this is the answer. If you want, you can write one more step. 1 by s plus s by s squared plus 16. Next, let us see another problem. This is L of sine cube 2t. We don't know the exact formula for sine cube, so what we are going to do is to find the solution. I am going to use the sine 3x formula. So this is 3 sine x, we all know this is a trigonometric formula again, minus sine cube x. We will use this formula to find sine cube x. So therefore, what will be our sine cube? Sine cube x will be 3 sine x minus sine 3x by 4. So what we have here? We have sine cube 2t. So instead of x we have 2t. So this can be written as 3 sine 2t minus sine 3 into x. So our x is 2t. So 3 into 2t. So this will become sine 6t by 4. So now let us apply the Laplace transforms. So therefore L of sine cube 2t is equal to, let me take this 1 by 4 outside. So into 3 into L of sine 2t minus L of sine 6t. Now let us apply the Laplace transform formula. This is equal to 1 by 4 into 3 into, so what is L of sine 2t? So sine 8t is a by s squared plus a squared. Here a is equal to 2, so it is 2 by s squared plus 2 squared minus, here it is 6 by s squared plus 6 squared. This is equal to 1 by 4 into 3 into 2 is 6. 6 by s squared plus 4. So this is 6 by s squared plus 4 minus 6 by s squared plus 36. So 6 by s squared plus 36. And this, if you evaluate, you will be getting 48 by s squared plus 4 into s squared plus 36. So this is the answer.